It should work now. Let me check all the settings. Quit Telegram sounds. Recording. Properties. Levels. Listen. Custom. AGC. I really want to know what this feature is about. What is AGC in mic settings? Yeah, AGC. Okay. Automatic gain control. Yeah. That's what I wanted. That's what I really wanted, chat. Okay, let me turn this off. So I've been doing some filming, some GitHub. Been learning GitHub over the past few weeks. If y'all watching the stream, hit that like button, y'all. Like then I can know how many people watch the stream. Let me see the participants. Just bearing in mind. Dang. Dang. Introduction to GitHub. This is what I've been doing, chat. I've been doing this introduction to GitHub. Oh my god, what is this? If I click launch OBS, the stream will end. Holy moly. I'm gonna do it later. As you complete each step, I'll update in the comments. Check your work and guide you forward. Share helpful tips and resources. Celebrate your progress and completion. Let's get started. Good luck and have fun. Create a branch. What is GitHub? GitHub is a collaboration platform that uses Git for versioning. GitHub is a popular place to share and contribute to open source software. What is a repository? A repository is a project containing files and folders. A repository tracks versions of files and folders. For more information, see About Repositories from GitHub Docs. What is a branch? A branch is a parallel version of your repository. By default, your repository has one branch named main, and it is considered to be the definitive branch. Creating additional branches allows you to copy the main branch repository and safely make any changes without disrupting the main project. Many people use branches to work on specific features without affecting any other parts of the project. Branches allow you to separate your work from the main branch. In other words, everyone's work is safe while you contribute. For more information, see About Branches. What is a profile README? Is essentially an About Me section on your GitHub profile where you can share information about yourself with the community on GitHub. GitHub.com. GitHub shows your profile README at the top of your profile page. For more information, see Managing Your Profile README. I really want to get this done. No cap. I'm currently working on something cool. I'm currently learning with help from docs.github.com. Ask me about GitHub. Prerequisites. 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 I ain't gonna lie, I'm kind of tired, chat. You created a repository with a name that matches your GitHub username. The repository is public. The repository contains a file named readme and it's root. The readme MD file contains any content. You all feel sleepy after drinking some milk. Okay, what? Bro, like, I slept all day long today. Like, what's going on, bro? Damn. Turn, turn it in. What is turn it in? What is turn it in? Plagiarism detection service and academic integrity tool used by educational institutions. Vast database of academic papers, websites, and other student work. While it flags potential issues, turn. Mhm. Oh.
Okay, here's an idea. What if we just spend 15 minutes talking about Prime trying to get his video done, and then we all say we have to leave?
He says so much F. Language productivity myth. By the way, I'm actually extremely excited about this. By the way, what is this AI nonsense, dude? Would you use like Chat GPT-2 to generate this article? What kind of image is this? I mean, look at the figures. Damn, this man has seen Nom. But real talk, this is like really, 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 I think this is a super interesting topic because this has been one of the biggest debates that's been going on, which is the reason why you choose TypeScript from both the front end to the back end is that you have this productivity gain. So I'm just trying to give I'm trying to give first the case for a single language productivity. And so that means if you say you have a function called validate user input, right? Depending on it doesn't matter what form it is, you could actually have validate user input that hands you back out the errors. You're able to take those errors and then you're able to apply them both to your front end and give nice validation errors on the front end, and then on the back end you actually share that logic so you don't accidentally have this oopsie daisy where you have one side validation that is really good and one side validation that's really bad or incorrect. Okay, so that is like the defining kind of argument for why you want one language, is the ability to share types and logic between the application on the front and back end. Does that make sense? By the way, this is what I always tell you. If you cannot understand why someone would make an argument, you first need to understand the argument itself. Okay, full stack type safety is nice. Okay, so again, full stack. I forgot to turn off alerts. Full stack type safety and one language aren't the same thing. Okay, you can have full stack type safety and be in two different languages. Okay, that's just a made up problem that you've made up whenever you think about these things. Okay, I'm sorry, I'm not trying to be rude, but that's a made up problem. Okay, all right. And what I mean by made up problem is that there is other encodings that encode type information into it. It's easier though. Again, you've made that up. It's really not. No, real talk. Why is it not? Have you heard of protobufs? Have you heard of Captain Proto? Have you heard of flat buffers? Have you heard of any of these other encoding schemes that include type safety on top of transfer protocols? gRPC. Have you heard of any of those things? Because if you do, then you'd realize that type safety and type information can be contained at the request level or at the various levels. So thus, you do not need to have the same language on both sides. Okay, message pack. Doesn't that also? I'm not sure if Message Pack does, but I haven't played enough with Message Pack. Message Pack is JSON plus. You know what I mean? And so I use JSDoc for type safety. Yeah, there you go. Anyways, so when I read these kind of things, it feels much more crappy to use these workarounds. That is my general point. See, I don't think it's a workaround. What workaround are you talking about? You're adding actual encoding safety, meaning that when you request something from your back end, you actually have encoded safety. You're actually enforcing it at an encoding level to be something. Whereas when you do this and you just simply have JavaScript says it's this type, you're not actually doing it. You're doing a runtime validation, something like, what's it called? Zod. There you go. Zod is a runtime workaround for the fact that you do not have encodings, okay? Full stack development and full stack type safety existed before TypeScript. These aren't some new concept that only just recently happened, okay? How do encodings work? They're just binary encodings with typing information inside of it. So just imagine the fact, like when you transfer down JSON, you transfer down video title, video description, da-da-da-da, da-da-da-da-da, da-da-da-da-da. In a binary world, you just have those values inlined, and then you have a type enum at the type that says this type is this. And so then it can understand and parse through that thing really easily. Does that make sense? It just makes it so that there is it's just like, imagine if you're programming in C and you took a struct and looked at it in memory. Now imagine if in front of that struct, you put a byte that says what type of struct it is. That way you could actually read through memory and understand which every struct is without having to pre-type it effectively, or without having to do some sort of weird guess typing. You could actually have something that just returns it out, right? That would be like the idea. Okay. Yeah, pickle. Yeah, pickle for what's it called? Python. I'm not sure if pickle does it, but okay, awesome. Why do that when JSON is better? JSON isn't better. JSON is just simply an encoding. In fact, what people often will use is they wrap protobufs over JSON. They'll use JSON as their transport medium so that they can look at the request and understand what's happening, but they have protobufs doing the back and forth transferring so you actually get the types out. You get real types out defined as opposed to just JSON and you saying this JSON is this type. And then you don't have to do runtime validation because it's already been validated at a protocol level, not at a runtime level. So these things do exist. They completely exist. And like using something like TS prototype is super, super easy. Or CS protobuf is actually super duper easy. It's shockingly easy. Just become a college professor at this point. Yeah, but the problem with the college professor is that college professors are largely abstracted from the world, whereas I have plenty of, I work in the real world in which we use protobufs to transfer stuff because protobufs are superior when you're transferring between many different languages. If you want real full types, like full stack safety from all the way from your store all the way to your front end, you're going to need to use something. Okay, because often databases are not, they're sitting on their own thing. And if you really need to get efficient, you're going to have to write services around very, very unique things. And they may not be written in your little TypeScript language, okay? Your nice little type, like a lot of us don't have the ability to afford 1 gigabyte per process because we want to use a simple language that gives us type safety. I'm just saying. Okay, so now that you understand why I would argue for it, which is that it gives you the full stack type safety, you get to write in one single language. One single language is a huge value. I totally buy the one single language per stack idea because that way you don't have to have any sort of head knowledge or you don't have to have any sort of context transfer between two different languages. As somebody who writes a lot in multiple languages, I do not think it's hard at all. But nonetheless, saying the argument, you only have to have one language to be able to write either front end or back end. You have the same libraries that you can share between front end and back end. You have the ability to share validation between the front end and the back end. You have the ability to define types in one language from the front end to the back end. Like these are all very positive things. So there you go. This is the single language productivity myth that we're going to address. Can Mirko be able to help us understand? Let's find out. All right, it's great because you can use the same language on the front end and the back end. I don't think it's great, actually. All right. This is a pretty common assumption in the JavaScript world. It is. That's why I noticed that when I talked about all this, I talked about it in perspective of TypeScript because this is a TypeScript/JavaScript take. You typically don't see this in any other language. You gain productivity because you can use the same language on the front end and the back end. But why exactly? How are you gaining productivity? I just add the word ing. How do you gain productivity? How much and how much? Some common arguments and baked-in assumptions are you only have to learn a single language. You can share code between front end and back end. You get type safety between back end and front end. Easier development. Okay, there we go. Like I feel pre-read maybe or pre-heard this argument 10,000 times. Okay, Rust mentioned. Was Rust mentioned in here? Maybe. Let's see. It's hard to disagree with any of these in theory. Again. Oh, deployment? Easier deployment. Okay, so I did misread. Okay, I did misread, and I am sorry. I would just like to say sorry to everybody in my lifetime. All right. It's hard to disagree with these with this in theory. All these being equal, everyone should choose to write a front end and back end in the same language. But all else is not equal. Okay. Why? The arguments. In any real project, you already use more like 7 languages. HTML, CSS, JavaScript, TypeScript, Tailwind, Squeal, Prisma, Vite. Okay, some of these are not languages. This is just now you're just getting crazy. Is Vite considered a language? I don't think so. Is Prisma considered a language? No, Squeal is. Tailwind's not a language. TypeScript is like TypeScript just sparkles on top of JavaScript. CSS, HTML. Is HTML a language? Now you're trying to trigger me? Or is this over turning into a fist fight here? YAML. I don't think YAML is considered a language due to the fact, I know it has the word language in there, and a bunch of dumb people will be like, well, actually it says the word markup language, so therefore it's a language. That's not how languages work. A programming language contains logic, okay? You have to be able to do logic in it, okay? I hate to be the person to bust your balls, but you can't just call everything a language, okay? Language, not a language. Serverless versus server, I'm not even sure how that's a language, okay? I'm not sure what's going on here. Vercel, that's a company. Docker, one could argue that anyways, 8 config.js files, this is hilarious. Okay, that's funny. Maybe he goofed up on this one. Okay, he did scare quotes the languages, so maybe that's what he's saying. He's scare quoting the languages. So, okay, article busted. You switch between so many languages, tools, and systems constantly. One more is not going to kill your productivity. I don't like this as a general argument for it. Okay, I don't like that as a general argument for this.
Jupiter, what's going on, bruh? It's been a long time. It's been a long time. Let me ping your bro. Why I can't control the comment? I mean the chat. I cannot do anything. Oh, cause I haven't logged in. That's why, right? Oh yeah.
Just one more.
How's your day going, brother? How's your life? How's your life? How have you been? And things of that nature. Let me tell you. Just tell me about your life.
Won't kill you. Well, I would argue that's the whole point of you trying not to do this, is that you have one less, right? Vercel, the language. Knowing front-end JavaScript gives you almost no advantage once you want to create a server that takes in a request and responds back with JSON. This is, okay, now that's a great argument. This is a great argument right here, right? Which is, just because you know one thing doesn't mean knowing the language somehow gives you an automatic W, right? Just because you understand how to color a box using style properties on an element doesn't mean you understand how to do a request response with the server, right? Now you may feel more comfortable because you already know the syntax, but a lot of syntax is most languages are C based that you're going to run into in the professional world, so you're already going to have like a general just understanding to begin with, right? Let's see, if you want to learn that, you have to learn Squeal, how to model your tables entities, Prisma, ORM, how to authenticate on the server, how to run long-running expensive stuff in the background, how do you even route incoming requests, how do you respond back with JSON, how do you respond with the 404, when do you respond with the 404, how do you do middleware, how do you accept a file upload and store it somewhere, how do you generate an OpenA API definition, what even is that, what the F is this course thing, where do I host it, how do you set up your pipelines and deploy automatically. This is actually quite fantastic. This is like the plight of the new programmer. This is the plight of the new programmer because a lot of us have a lot of these things baked into our head and they just seem normal. But imagine just like coming into this for the first time. It's been so long since I've had to experience this jolt. We didn't even have middleware when I started, okay? Middleware wasn't even a thing. That word didn't even exist when I started web programming, okay? Programmers, dude, I barely understand cores, okay? Okay? I barely understand it. All I know is when something goes wrong and it's cores, I know I'll be Googling. So what is middleware? Middleware is between the client and the server. It's this thing that's on the server that does stuff to your request before your request is handled. And sometimes it's also between your server and the client, okay, doing stuff. It's a man in the middle, but it's not like a man in the middle attack. It's a man in the middle that helps you gather your stuff, right? It can do stuff. It's a filter is a nice example. A real example, if I'm going to just be real and give you guys like good information, a good middleware would be like, say you're writing a server and you have authentication. Authentication could be a middleware. Is this request authenticated? No, it's not. Okay. I'm going to put that information in there. Next middleware. Is this route require authentication? It does. We're going to have to respond with whatever type one you need to do. I forget which 400 is the you're not authenticated, you need to suck it method, but whatever one that is. Okay, middleware is the thing that happens before your actual one. 403, 401, I forget which one it is. I'd have to just go look up unauthorized, right? Unauthorized. Which one's on 403? 403 is unauthorized. People saying 401. No, what is unauthorized? Unauthorized HTTP code. 401 unauthorized. That's the one you'd want to use. You wouldn't want to use 403 is forbidden. I don't think forbidden is the one you want. 401, the unauthorized, is probably the one you're looking for, right? This one's specifically stating the intent. I mean, really, if I were you, I'd probably use 418 HTTP code, okay? This one is probably the best one to respond with in all situations when you don't know what's happening. Just hit him with the 418, okay? Naturally, just the best, okay? It just is. What's wrong? I don't know. You're a teapot. Or I'm a teapot. I'm a honeypot. Imagine having to figure out all these for the first time in a Node app versus a C# app. I'm not sure which one's worse, as I haven't developed.
My brain is like cooked now. Like, I don't understand anything he says. Oh, I hate Rust.
Let's get rusty. Let's get rusty, boys.
Developers hate Rust, despite Stack Overflow claiming Rust is the most loved.
Did Google just F up? What is this? What is this view you just did, Google? It's like half there, half not there. What is that? All right. There we go.
Language year after year. I haven't seen this much genuine hate for a programming language in a long time. It's gone so bad that merely mentioning Rust
That's a W. That's a W. Can we get a W here? Let's go. Let's go. That's a W right there.
can trigger developers. But this hate isn't all unfounded, and it usually stems from 5 reasons.
Ooh.
The first one being lack of job opportunities, to which I just
Well, let's hear what he has to say.
have to say. The second reason
There's one thing that remember, of the jobs that are available, it's still like 75% crypto bros. Solana's gonna make it, man. Like, dude, it's just like, that's, you know what I'm saying? You know what I'm saying? And the second thing is that if you watch the Stack Overflow survey from last year to this year, there were more people satisfied in using Rust percentage-wise at their job, but there were less people overall using Rust at their job. And they used percentages. They didn't even like, it wasn't even oh my goodness, dude. It was that chart. I'm still triggered to this day by Rust Foundation's chart, or whatever, whoever runs the Rust charting year by year. It was the most misleading, nonsensical thing I've ever seen in my life. Dude, it was marketing to like it was marketing to a T, and it was confusing as it gets.
developers hate Rust is the syntax. People say it's verbose, complex, and downright ugly. For comparison, let's take a look at the map method, which transforms a collection of one type to another type. The function signature in JavaScript is extremely simple, whereas in Rust it gets pretty complicated. We see generics, trait bounds, closures, the size trait, and this signature
Ain't nobody knows what the size trait is, okay? I know there's a lot of people in this chat, they're gonna be like, oh, I totally know that. No, you don't. You don't know it. Don't even try it with me. You have no idea what's going on.
doesn't even include lifetimes. So yes, the Rust syntax is more verbose, more complex, and frankly more intimidating than a lot of other languages. But there are some good reasons for this. Rust is a statically typed language which favors explicitness in its type system. And it also has to model things like memory safety in its type system. The benefit of this is that it reduces ambiguity, which in turn reduces errors. The map function in JavaScript doesn't tell us what the type of the input parameter should be, or what the function returns, if anything. Developers have to dig into documentation to figure that out. This opens up the door for runtime errors, because a developer can literally pass in anything to this function. The map method.
He does make a really good point, which is if you're unfamiliar with just static, I mean, Rust is a particularly egregious version of this all. Like, it does just simply have the most verbose syntax. But if you're familiar with any statically typed language, you will quickly become a fan of it because you no longer have to go and like guess what the thing does or go and like read documentation on the internet. or use your LSP to bring it up and try to like infer the types through whatever you're looking at. You can actually, it's like right there. And so there is something that's very, very nice about having a good function signature. And this is really what TypeScript, this is like half the reason people love TypeScript is the fact that you have this.
In Rust, on the other hand, tells us exactly what it expects as input and what it returns as output. The code documents itself, and developers are required to follow this function's contract, otherwise they'll get a compile time error. By favoring explicit syntax and having a strong type system, Rust ensures your code is predictable, consistent, easier to refactor, debug, and maintain.
I'm curious about that last one, easy to refactor. I would challenge that one once you get into lifetimes. Like if you went from like make it work, make it correct, make it fast kind of like approach to software, the making it fast, once you start throwing in one lifetime, it will propagate through your whole code base. It's a very leaky, odd thing that happens. Easy to refactor. I mean, I've refactored some Rust. I've done quite a bit of Rust and quite a bit of refactoring of it. And it's a fairly easy language to refactor. Like, it's not that bad. It's just that adding stuff to it, especially when you're especially like lifetime stuff, can become really difficult. And then refactoring in that sense becomes really difficult. And so typically, all the stuff I write that I used Rust for, I just used clone and just avoided it during pretty much the entirety of the process until I really determined that I need to make things better. What's the opposite of refactor? Refuctor. A refuctor is where you take the program and you change it.
Better languages out there. First of all, we have C and C++, which are both low-level and performant. If you're looking for simplicity, you can go with C. And if you're looking for a language that's object-oriented, has modern features, and a mature ecosystem, then you can go with C++. Not to mention that both C and C++ are established, widely used languages with plenty of job opportunities.
That's very fair. That's very fair. It's actually fair. When he says simplicity, what he means by simplicity isn't that writing C is simple. Is that the language itself is simple, right? Like you can learn all of C syntax in a fairly short period of time. So C is simple. Simple does not mean easy. So you have to understand the difference between simple and easy. And so that way, if you don't do that, you're not gonna understand when people say these phrases, because like how short you could, like K&R, the book K&R is like what? You could read it in a day. It's simple. It's just really hard, okay?
On the other hand, you have Go, a language that's laser focused on simplicity, great for rapid development, and with an excellent concurrency model, it's especially great for building network services, such as web servers, APIs, and microservices. It's also great for CLI tools and automation scripts, and there are plenty open Go job positions. And then, of course, we have Zig, a language.
Hey, by the way, Mr. Rusty over here giving a positive review of Go. That's a lot of respect on him. People have to be able to recognize the strengths. Like I recognize the strengths of what makes TypeScript good. And it's the same thing. It's like Tailwind. If you overuse Tailwind, you get into this place where I think you no longer make it good. I see the same thing with TypeScript. TypeScript has a bunch of really strong points. When I'm developing a front end, I'm going to use the TypeScript compiler. I'm going to use JSDoc to like enable those things because JavaScript without any types is crazy talk to me. And so like I'm fine with all those things. How can we never recognize the greatness of C#? Because I don't wear pleated pants, Pisco. I like
language that also focuses on simplicity.
Zig.
In fact, their tagline is focus on debugging your application rather than debugging your programming knowledge, which I feel like is a shot at Rust, but I'll let it go for now. Zig has no...
By the way, Zig is absolutely incredible. It is one of the most clever languages I've ever seen.
No hidden control flow, no hidden memory allocations, and no preprocessor or macros. This results in fast compile times and seamless compatibility with C and C++ without needing bindings or wrappers. It also includes some safety features like bounds checking and comes with a package manager and testing framework. So with all these...
It also has options, so you avoid the whole nil thing a lot. It also has these nice little typed unions, so you can do error handling, more kind of Rust styles where you can get the value or the error. It has some nice keywords around it, so you can try the function and pull out the error or pull out the value or return out the error. There's a lot of there's a lot of nice little things like it. Isn't comp time kind of like macros? Comp time's kind of like macros. It's not quite the same, right? A Rust macro, it's more like a declarative macro, but you're just writing Zig. That's the difference, is that a declarative macro in Rust, you write out, there's like still a lot of a bunch of special things and symbols you have to know. And then doing a procedural macro is even harder, right? It takes a lot of mental overhead. But doing a comp time thing is you're just writing Zig and you're saying, instead of like int, you're saying type. It's like a generic. It's like the halfway. It's more like writing a generic, right? You get that experience where you're just writing the code and the generic is just kind of placed in there and you can do the operations on it. It's really incredible. And then you just instantiate, or I'm not even sure if that's the right term. You specify the comp time what you want to use. I want to be able to have a queue with an int. I want to be able to have a queue with a this, and it will make sure that at compile time it has those. It's very, very clever.
Options, why would anyone use Rust? Now, I'm not going to sit here and tell you should use Rust for every single use case, even though that's absolutely true. You should use the right tool for the job, and there are certainly cases where C, C++, Go, or Zig is the right tool. But Rust solves a major problem in the systems programming space in a way that no other language has. Rust gives you an extremely high level of performance coupled with an extremely high level of memory safety. In Zig, if we create an array with one element and then deallocate that array, we can still attempt to access the first element, which will result in the program crashing at runtime. In Rust,
this is true.
If we tried to do the same thing, we would get a compile time error because the ownership rules would prevent us from making this fatal mistake. This is why we're
It is better. Like that is a good reason. Typically you'd use defer, so Zig also has defer, so you can actually execute code after the function ends, which is super cool. I love that from Go, by the way. You have that option. But nonetheless, he's absolutely correct. You can still get a use after free.
Seeing Rust get adopted for critical software like cloud infrastructure at AWS, the world's largest operating systems, Windows, Linux, and Android, and mission-critical software in the aerospace industry, automotive industry, and other embedded devices. For these use cases, Rust is proving to be an excellent tool. The fourth reason developers...
I will say that I think that if Zig came about earlier and was at this...
It could be a little much. Everyone is entitled to their opinion, but the numbers and success stories don't lie. Rust's momentum is continuing. 1 million new Rust developers joined the community over the last 12 months. Rust subreddit has now surpassed the C++ subreddit, and Rust continues to be voted the most loved / most admired language year after year. And we continue to see industry adoption by tech giants like Microsoft, AWS, and Google. So is the hype real? In my completely unbiased opinion, yeah, Rust might be a little overhyped, but the hype is certainly real. But
this is a really good take. I really appreciate this take, which is there's a lot of momentum. And Twitter is a really shitty place to get information. So yeah, it's probably hyped up too hard on Twitter, but it is a great language and it is seeing adoption. It's just, we got to get the jobs, you know? The jobs still aren't there. I think that's the biggest thing, is that if jobs start opening up to like the average person, I think that it will become huge. I'm seeing a lot of Fs. What kind of Fs are we talking about? So I just want to make sure. Is this Fs as in the stream or F as in this? No F? I don't F? Yes. Are you guys effing around on me right now? Are you guys effing around on me? Stream is fine. You just dropping a bunch of Fs. Oh my goodness! Reload, dude. You can't be just dropping Fs like that, dude. Casually effing me is just not the way to get me to notice you. Actually, it is. It is exactly the way to get me to notice you. Please don't casually F me, okay? It's like, I trust you guys. I trust you guys so much. I know coordination was the key. A bunch of you started saying F. Confused me, got me scared.
Don't take my word for it. Look at the numbers, look at the success stories, and try it out yourself. On the other hand, some developers hate Rust because of the drama. It's no secret that the Rust Foundation has had its share of controversies. Entire teams leaving, the restrictive copyright policy draft, which sparked backlash, and other governance-related issues. Besides these specific issues, some developers see the Foundation as too woke in general. As a result of these controversies, a fork of Rust was created called Crabling to protest back.
Did we just get a Tech Travi Savvy mention? Did we just get a Tech Travi Savvy mention right now? Did we get it? Did we get always no? I do.
To Rust, I definitely have some thoughts on this. In general, I think the drama is a bit overblown. I do genuinely believe that
I spent 18 months rebuilding my algorithmic trading platform in Rust. I'm filled with regret. I would love it if this article was like, I'm filled with regret for not doing it sooner. Like, how funny would that be? All right, Austin Starks, take us on. not a real database. It's a key value doc. We really should be very careful about that. Don't. I think it is good insights in the sense that the pit of success is extremely hard to fall into with Rust. And I think that if you're going to do Rust, you got to learn